Good afternoon, ladies and gentlemen. My name is Razuks-Ebels, and I am the CEO of AlloyAdvisor. And today I will be sharing with you our next generation and next level titanium defect analysis technology. But first of all, what is titanium? Titanium is a lightweight yet very durable and corrosion-resistant material that is highly sought after by high-performance industries such as the aerospace, medical, oil drilling industries, and the likes. And titanium alloys by itself is a 3 billion and growing global industry. However, there's a fundamental problem with the way we produce titanium these days. The most common method used by far is the VAR method. Yet the VAR method is highly susceptible to the formation of gaseous defects, which is obviously not a good thing. Whereas defectless methods do exist, they are very expensive and technologically complex, making them unattainable to many manufacturers. As a result, countless hours, resources are lost to defect detection, removal, and reprocessing. And despite these extensive efforts, defects still manage to reach end products, meaning that they cause pain and losses to individuals in the cases of medical defects in implants and resulting in class action lawsuits against manufacturers. In the case of United Airlines Flight 232, a single titanium defect led to the deaths of 111 people, highlighting just how serious a problem this is. As a result, AlloyAdvisor has developed a solution that is of next level quality control. Nothing like this has ever existed before. We propose, instead of struggling with removing defects as they appear, eliminating or preventing them from reaching production in the first place, so eliminating them from the production line. So the best way to think of AlloyAdvisor is as your personal doctor. We obtain a sample, as the doctor would obtain a sample of blood. We conduct an analysis, and then we provide suggestions, just as the doctor would identify where in the body the problem might lie. With our results, the manufacturer can identify where in the production line the defect source lies. A little more specifically, we use something called nuclear reaction analysis, and the process looks something like this. First, we obtain a sample of defective titanium, we rent a particle accelerator, conduct our analysis, process the results, and then offer a diagnosis with an accuracy of close to 100%. The manufacturer is able to use this diagnosis to pinpoint where exactly in the production line the defect source lies. But wait a second, you must be wondering, rent a particle accelerator. Isn't that something prohibitively expensive, inaccessible both in terms of arranging it and in this map of major particle accelerators, nowhere close Latvia where we're located? But that's actually not true, because these are the major accelerators and research centers which are at the groundbreaking cutting edge of particle physics. The closest accelerator is actually just 14 minutes away from this room, which means that there's a great abundance of accelerators that work for our purposes. So now that I've established what we do, let me give you an example of our first case study, first successful cooperation with our first partner, which is VSMPO. And it just happens to be the world's largest titanium manufacturer. It's a major supplier of Boeing, in part because of its outstanding quality that it has guaranteed, and we have helped in our last 15 years of cooperation ensure. So in these 15 years, we've developed and perfected our technology with this partner. We've helped them to virtually eliminate all gaseous defects from their production line, and yet we still continue to cooperate as new defects arise due to changes in production, raw materials, or the wear and tear of machinery. And VSMPO is not the only company out there we would like to work with. We've identified 20 major manufacturers of titanium across the globe, anywhere from Europe to China. And we believe the right approach here is to approach each individually, as they're sufficiently large and there are sufficiently few of them for it to be feasible. We believe it be imperative that we also partner with the end manufacturers of titanium, such as Lockheed Martin, Airbus, Philips, Siemens Medical, and the likes, because these are the companies which often set the quality standards for manufacturers, and we can entice manufacturers into using our technology through them. So what is our business model? As you may have guessed, we offer our analysis as a service. And this is what we have done so far with our first partner and how we plan to proceed. At a second level, we can actually have the manufacturer bring us in, introduce us to their production line, and we can help pinpoint ourselves exactly where in the production line the defect source lies. Later down the road, once we will have automated our process using software and an instruction sheet, we will be able to license our technology to those manufacturers who want everything done in-house and who believe they want full autonomy and privacy in their activities. But I've spoken a lot about us, what we want to do, and what our ambitions are. So who are we? Once again, my name is Martins, and I am the CEO in charge of the business end. I have experience so far with 4 startups, and I'm a graduate of the Stockholm School of Economics. By my side is the Commercialization Reactor that's actively helping me with business development. And our research and development end is headed by a very experienced scientist, Vladimir Vyhodets, who is head of laboratory and lead researcher at a major Russian research institution. I would like to draw your attention to the fact that we are looking for door openers and advisors from the titanium industry as such. And now, somewhat on our funding needs. Currently, we're looking for a pre-seed of 50K, which would enable us to demonstrate and sell our technology or services to 2 new customers. And the goal is to transfer our technology, our business to Europe from Russia, where it currently lies, and eventually further down the road to the rest of the world. A prudent estimate of what we will get out of this is sales of 40K from 1 paying customer. And we plan to start a showroom here in Latvia for our technology, predictably in Mārupe, where the closest accelerator is located. We've also thought about our steps, which we will take later down the road, and I'll be glad to elaborate on them later. And finally, just a brief note on our IP. Our IP consists of our know-how of particle beam focusing. This nuclear reaction analysis method I mentioned has been around for quite a while, but in 50 or 60 years of its existence, we are the first to successfully be able to focus this beam of particles to create an accurate analysis tool. And as we are a very early stage startup, we are currently still looking into our patenting possibilities. So thank you very much for your attention.